the demonstration of the ABB synchronous reluctance motor together with the drive package. My name is Glenn Pike from Control Logic. I'm the Business Development Manager here. What we have is a ACS 880 drive that is controlling two motors, the inductive motor on the right and the synchronous reluctance motor on the left. What you would see from this angle is that the inductive motor is slightly shorter than the synchronous reluctance motor. We're going to now move around and I'll be able to show you the shaft heights and how these heights are similar. In fact, they are identical. We have the two shaft heights that are identical in height, and that will enable you to interchange the one motor opposed to the other. If you look at the bolt holes required to actually mount the inductive motor and the synchronous reluctance motor, they are identical. While we're talking about things that are identical, these are two 11 kilowatt motors. The stators are identical between both motors. The only difference is the rotor, and this is where the efficiencies come from. What you will notice immediately is that there are no windings on this rotor. The windings would have heat losses. Those heat losses would induce a heat into the bearings. By reducing the windings to zero, we have a 45% reduction in bearing temperature. If I move across and I take an illustration of this rotor, you will see a simple magnet on the stator. This will be the north, that will be the south. If we took iron filings and we sprinkled them on this sheet, you would see that they would actually draw these natural flux lines. Okay, so the rotor is designed to have the minimum reluctance across these paths. When we're talking about minimizing the reluctance, we've also minimized the air gaps to minimize the reluctance. So why do we want to minimize the reluctance? Because we want to increase the flux and induced energy into this rotor, and that is where the efficiencies come from. The next thing that we're going to talk about is peak inrush current. So we have an illustration here of the inductive motor. This is the peak inrush current, and the synchronous reluctance motor and the peak inrush current. Joe, go ahead and please start the inductive motor. Here we can see that the peak inrush current is 15.84 amps. We'll wait until the motor reaches 1,500 RPM, and then we'll shut down and we'll do exactly the same thing with the SynRM motor. Joe, go ahead. So we are now using the exact same drive. We are swapping over to the synchronous reluctance motor, and we're starting up, and we will see the peak inrush current. Peak inrush current for a synchronous reluctance motor is 6.1 amps. So the difference between the two is 62%. That's reducing your peak load and hence saving on your energy bill. Joe, go ahead and switch that off. The next portion of the demonstration comes down to tariffs. The energy tariff on your site might differ to this, and we'd welcome the opportunity to enter your parameters in here. I'm going to use an average of 15 cents per kilowatt hour for a site. It's a fan, it's running 24 hours a day, and it's running 365 days of the year. So when Joe starts now, I'm going to reset the peak inrush current to reflect the actual current draw at 1,500 RPM, because once it started up, it's going to be running 24/7, 365, and that's the only draw that you are going to experience. So we're at 1,500 RPM. I'm going to reset it. And now the actual current is reflected here. Joe, go ahead and stop that, please. Once the motor runs down, we're going to start the synchronous reluctance motor and see exactly the same thing. Once the RPM reaches 1,500 RPM, which is 50 Hertz, we are going to reset the peak inrush current to reflect the actual current draw, which will be what you would be drawing on a daily basis. So we're at 1,500 RPM. I reset to reflect the actual current over here. What we're seeing is a difference of 2.1 amp draw, the 29% saving using the synchronous reluctance motor, and you're saving $1,948 per year. That is a significant saving, and your return on investment is definitely there. I'd welcome the opportunity to discuss this further with you. I'm Glenn Pike from Control Logic, and I'd welcome the opportunity to talk to you further. Thank you.